Okay, so today we're going to start reviewing for our quiz on sections 1 through 3 of Module 5. So the first question says, find the measure of each interior angle of a regular 24gon. So this would be some polygon with 24 sides, which I won't attempt to draw. So we know the total interior degrees is given by the formula n minus 2, where n is the number of sides, times 180. So in this case, since we have a 24-sided figure, the total number of degrees would be 24 minus 2, which is 22, times 180. So if we take 22 times 180, we get a total degrees of 3,960. So that's all 24 angles added together. So it wants to know each interior angle, so we'll just divide this by 24, because since it's regular, they're all the same. So if I divide that by 24, I get 165. So this is each interior angle is 165. Now for exterior, if you recall, exterior angles always add to 360, no matter how many sides there are. So the exterior angles always add to 360. And I simply divide that by 24 to get each exterior angle. And that is, of course, going to give me 15. So that's each exterior angle. So the big formulas to remember, this is the total number of interior degrees, and the total number of exterior degrees is always just simply 360. Okay, so let's look at problem 2, where we're dealing with this parallelogram. So it says BE is 2x minus 6. So BE is this segment right here. That's 2x plus 6. And ED, which is this segment right here, is 5x minus 12. Now we had lots of properties of parallelograms. We know the opposite sides are the same. We know the opposite angles are the same. We know the consecutive angles are supplementary. But we also had this idea that the diagonals bisected each other at this middle point, which would be E. So since these are both halves of this diagonal BD, so these are both halves of that, these two expressions would be the same. So to solve this, we'd simply say 2x plus 6 equals 5x minus 12. And I'd solve that. So I'd subtract 2x from both sides, and I'd add 12. So 5x minus 2x is 3x. 6 plus 12 is 18. So I divide by 3. It gives me an x of 6. But this problem says find the length of BD, the whole diagonal. So I'll have to plug x in. So since we know BE is 2x plus 6, it's 2 times 6 plus 6, which is 18. So that's telling me that BE, is 18. But the other part has to be the same. ED would be 18. So BD, which is the whole diagonal, would just be 18 plus 18, which would be 36. So again, one of those problems where we solved it setting them equal, but then you have to be very careful of what you're actually looking for in the problem. All right, here's another problem dealing with our parallelograms. And here we have these two angles that are opposite. Now, if you recall in a parallelogram, opposite angles are always the same. So these two angles, W and S, are the same. For future reference, we know that consecutive angles, so say S and T, those would add to 180. But these, W and S, are definitely the same. So we would just set these equal. So x plus 16 equals 2x minus 1. So I'd subtract x from both sides. I'd add 1 to both sides. So that gives me 17 equal to 1x. But what it says is it wants the measure of angle W. And the measure of angle W is 2x minus 1. So this is 2 times 17 minus 1. So this is 34 minus 1. So this is 33 degrees. So angle W would be 33 degrees, as would angle S, even though it doesn't ask for that. And just for fun, angle T, since S and T are supplementary, it would be 180 minus 33, which is 147. And then R, of course, would also be 147. So lots of relationships amongst those angles. Okay, so problem 4 jumps back to our interior angles of a convex 48gon. We talked about this in problem 1. The total degrees of any polygon is n minus 2 times 180. So in this case, 48gon, it would be just simply 48 minus 2 times 180. So this would be 46 times 180. So this 46-sided figure, so the angles get pretty big, so this should be a pretty big number. 46 times 180 will give us 8,280 degrees. So quite a lot of degrees, but we have, again, 48 angles, so quite a bit. It doesn't tell us to find each one, and it doesn't really say it's regular, so we don't really know that they're all the same. So we really just know the total degrees. Okay, so in problem 5 it says, let's look and find x. So what we have here is we have a four-sided figure, not a parallelogram by any stretch of the imagination, but four-sided figure. So four-sided figures, we know the total degrees add up to 360. So all of these angles should add up to 360. So we can set up our equation, 2x minus 12 plus 3x plus 2, and again, these are just the angle things I see here, plus x plus 30 plus x minus 10 equals 360. So if we add these up, we have 2, 5, 6, 7 x's. That's just adding together all four of these x terms. We have minus 12 plus 2, which is minus 10. Minus 10 plus 30 is 20. 20 minus 10 is 10. So the left side, just combining terms, gives me 7x plus 10 equals 360. So I'll subtract 10. So 7x equals 350. So if I divide by 7, 350 divided by 7 will give me 50. And that's what x is in this case, and that's actually what we're finding. We, of course, could plug it in and find the angles, but it just wants us to find x in this problem. Okay, let's look at problem 6. Problem 6 talks about a parallelogram, ABCD. Doesn't really give us a picture, so I'm going to draw a picture. So A, B, C, D. It says measure of angle A is 138 degrees. And it wants us to find the measure of angle B, which is this guy here. Well, in a parallelogram, we know the opposite angles are the same. So this one would be 138. But now to find B, it's a consecutive angle, so those have to add up to 180. So to find B, that's just 180 minus 138, which is 42. So this angle is 42. So the measure of angle B in our problem is 42. We also know that C is 42. It didn't ask for that, but again, opposite angles are the same. Okay. So let's look at problem 7. Determine if ABCD is a parallelogram if we have some information. So we had those four reasonings in section 3 that made a quadrilateral parallelogram. So ABCD. So it says AB is 6. So I'll write that in there. And it says BC is 12. And it says DA is 12. Is this a parallelogram? So for a parallelogram, we had a couple ways to show that was true. We had to have two pairs of congruent sides. So this is 12, this is 12, so that's 1. It says this is 6, but I don't know this is 6. Another way we could do was to say, hey, if one set of sides are the same and parallel, we could prove it, but this is just the same. It doesn't say that AD and BC are parallel. We could say that the angles are the same, but it really has no information about the angles. And the fourth way we could do is talking about the diagonals, but there are no diagonals here. So I would say there is not information to show it's a parallelogram. And again, I would refer you back to section 3 and all those 4 theorems. That was how we would have to show if something is a parallelogram. Alright, so let's look at this diagram where we have a parallelogram, MLKJ. Find MLK and LKJ. So MLK would be this entire angle here, and LKJ would be this angle here. And we know this angle here is 12, and we know this bottom angle here is 18. So what it's pointing to is it's saying that this little angle here is 12 and this little angle here is 18. So since these are parallel lines and we have this diagonal J, alternate interior angles would say this angle is 12 as well. And by the same rationale, this would be 18. So this angle in the corner is 12 plus 18, so measure of angle MLK would just be 30 degrees. So this angle here is these two together, which is 30. Now for angle K, or the way they do it is LKJ, is these two angles, so L and K are next to each other, so they're consecutive, so they have to add to 180. So I just do 180 minus 30 to get the other one, which is 150. Okay, let's look at our last problem. It says XYWZ is a quadrilateral with these vertices on the coordinate plane. Determine if it's a parallelogram. Use slope to justify your answer. So we had a theorem way back in the beginning of our class that said we could find slope by using this formula. y2 minus y1 over x2 minus x1. So we'll use this to find the slope of some of these lines. So here's negative 1, 4, which is W. We have negative 4 up 2. That's for x. Y is 1, negative 1, which would be somewhere here. And Z is negative 2, negative 3, which is here. So if I look at this, just kind of on eyeballing, it doesn't really look like a parallelogram to me. It doesn't necessarily look like XZ and YZ are the same. So let's find their slopes. So remember X was negative 4, positive 2, and Z was negative 2, negative 3. So if I plug that in my slope formula, negative 3 minus negative 4 becomes positive 4 over negative 2. Oh, I did that wrong. Let's try that again. So we're subtracting the y's, so negative 3 minus 2 over negative 2 minus negative 4, which becomes plus 4. So this is negative 5 over positive 2. So that is the slope of this line. So let's look at the slope of y and w. If you look at it, it's pretty easy to see that it is straight up and down, but we can certainly plug it in. So this is 1, negative 1, and w is 1, negative 4. So this is negative 4 minus minus 1, which is plus 1, over 1 minus 1. So this is negative 3 over 0, which is undefined. So these slopes are definitely not the same. One is a negative number, one's undefined. So we could say those sides are not parallel, so this is not a parallelogram. Remember the definition of a parallelogram, both sets of sides must be parallel. So this is definitely not. Alright, so this is the end of the review. Hopefully you found it helpful, and make sure you use this on your quiz. It will definitely help you out.